Welcome to the project demonstration of automatic power factor correction and monitoring same power factor values through IoT using Thingspeak. And here the main application of this project is, as we know that whenever we have connected an inductive load to the 230 volts, then due to the current waveform lags, the phase difference will increases between the current waveform and voltage waveform. So whenever the phase difference increases, as we know the cos phase difference, nothing but cos theta. The theta is going to be the phase difference between the voltage waveform and current waveform. Then the power factor value will be decreased from unity power factor. For example, if we connected the resistive load, then the phase difference between the current waveform and voltage waveform is nearby 0. Then the cos 0 is going to be the unit, it's a 1. And whenever the phase difference increases, then the theta value increases, so that the cos theta value of is going to be comes down to the 1 to around 0.9, 0.8, like that. Based on the phase difference value, we'll get the power factor value. And, due to that, there's a loss of power occurred, and due to the energy will be wasted, and we'll get the unnecessary power wastage, and extra current bill also will be occurred due to that. So in order to compensate that power factor, we are making use of a parallel capacitor. The shunt capacitor will be added in parallel to the L or L plus R load. So due to that, the current waveform leads, means whenever the inductive load is connected, then current waveform lags. Whenever capacitive load connected, the current waveform will be leads. So due to this, the compensation will be done with help of this capacitor by adding that capacitor in parallel to this R plus L using this electromagnetic relay. And this operation was calculated and successfully executed by our Arduino UNO board. And also parallelly, we are going to uploading the data to the Thingspeak with help of this ESP8266, and from these two, voltage and current waveforms will be captured by our Arduino UNO board, and so-called status continuously displayed on the 16:2 LCD screen. And this is a switch to connect this resistive load in series with the R load and disconnect that in series with the R load. And capacitor was placed in series with the relay in parallel to this R plus L. So the main components in our project is voltage waveform sensor along with the RPS board and current transformer, and in order to convert that to the low level voltages with help of this potential divider circuits, and ESP8266 Wi-Fi module, 16:2 LCD screen, and a mechanical switch, and inductive load which is a 40 watts of power, and capacitive load at 2.7 microfarad 450 volts, and a resistive load 100 watts and electromagnetic relay. And this is a main Arduino UNO board. So these are major components in our project. And as we can see, the data was captured into Thingspeak. For that, just log into the Thingspeak cloud platform, and you can see this page. So in my channels, we can see the power factor monitoring. So before demonstration, the very first step is we need to enable the hotspot in your phone along with data. The hotspot setting should be done in this manner of project 7026 without any space, without any capital letter, and next password is 123456789, and AP band should be 2.4 gigahertz. After enabling the hotspot along with data, then log into the Thingspeak cloud platform, stay on the screen, and yes, on the power supply to this cage. So this is the power cable, just on the power supply to this one. So initially, right, so when it is low intensity, that is indication of the inductive load was connected in series with the resistive load. So you can see one device is connected in your mobile phone. Right, one device is connected. Now if it is hang over there, just you need to reset, because the reset has to be done frequently. As we are using the AC, there is a humming noise, and the noise will be occurred to the system. Right, now we can see the power factor lagging 0.92. It is normal, as we don't get the unity power factor in the whole world with a only resistive load. And now when we add the inductor in series, then the voltage will be divided as when we are connected in series. So before that, go to Thingspeak. So there we can see the power factor values which are plotted here. So by clicking on the dot, we can see the date and time along with the power factor values. So if we want to get the fresh values, then just go to data import export. We can download that. Better to take the backup before erasing that. In export, download values. So it will be downloaded in Excel sheet format. You can just open that. So there we can see the Excel sheet of data, which consists of number of entries till now occurred and number of entries, entry ID and date and time. So there we can see the date and time here along with the date and time and power factor values. So there you can see the field 1 is the power factor values continuously plotted in Excel sheet. After you took the backup, now go to channel settings. In that, only do clear channel. No need to delete the channel, only clear channel. After clearing the channel, it will be pop-ups, and now go to private view. There we can get the old data got erased, only live data is continuously plotting. Now just we have added this capacitor lagging 0.75, and after some time it will be compensated, and right, the relay got switched on and the lagging power factor is 0.92. As we can see that the power factor is comes down to here 0.75 along with date and time. So when we disconnect this inductive load, only resistive load, as already the relay got switched on, that's why it is connected in parallel to this load. Then the power factor has to be lead. So nowadays when you add the inductive load, lags, after capacitor added in parallel, it will be leads, so that the power factor compensated. And when we disconnect the inductive load, right, you can see the leading 0.93, right, automatically the particular relay got switched off after it compensated, and you can see that now it is again lagging 0.9296 is based on the current waveform deviations. The values bit fluctuated but not the more. So you can see the same data is continuously plotting to this Thingspeak. In this manner we are going to compensate the power current waveform leads, lags, and correction of the power factor, and continuously monitoring on the LCD screen, as well as uploading the same data to the Thingspeak with help of this ESP8266 Wi-Fi module. And this data can be accessed from anywhere in the world, right? For every 15 to 20 seconds of duration, the data continuously plotting into the Thingspeak. Thank you.